We have an endpoint, but we're no closer to actually getting a URL out of this. We could stuff all this functionality into the type itself, but we're going to split up some of the work by using a protocol and defining what it means to be an endpoint. So up at the top, we'll say protocol endpoint. When we created the URL in Postman, we took it step by step, right? First, we specified a base URL. So let's add a requirement to our protocol that states that any type acting as an endpoint must provide information about a base URL. So var base string get. What next? Well, after the base, we need to provide a path. So let's add that as a requirement as well. So path is going to be a string. And notice that none of these are settable properties. See, we just want the type to return a URL and specify these values. So all that's left to do is append the encoded parameters to this URL's base and path. Now we could define a function to do this that implements the logic we defined in our playground. But there's a built-in way for us to do this already. I made you go through the whole process of doing all that work yourself so you understand what's going on under the hood. Really though, Apple has taken care of that for us, as always, and all we need to do is use a few different types. So URL query item is a struct that defines a single key value pair in a URL query. We pass in each key and value, and the encoding is handled for us. Since we have multiple parameters, we're going to specify that types acting as endpoints should provide an array of URL query item instances covering the range of parameters. URL query item is kind of like a dictionary. It takes a key and a value pair. So think of this as an array of dictionaries. So we'll say var query items, and this is going to be an array of URL query item, and this is also gettable. All our parameters are going to be represented in this array. Using just these components, the base, path, and query items, we have all the information we need to create a URL. In fact, this is exactly all we need. So we don't even need to let the type do the work to create the URL, and we can allow this endpoint protocol to do the work itself by implementing a request property in an extension. So we'll say extension endpoint. We haven't used this functionality in a while, but remember that you can provide default implementations in a protocol extension, both for requirements defined in the original protocol and for completely new requirements. So let's add a computed property that uses the base, path, and query items to return a URL request object containing the valid URL. To achieve this, we're going to use another struct that's part of the Foundation framework, URL components. URL components is a structure designed to parse URLs and construct URLs from their various parts. So before we actually work on the request, let's add a computed property to return a components instance. So var URL components, and this is of type URL components. First, we create an instance of URL components, and we're going to assign it to a variable since we need to mutate it. This is a struct, so it has to be a variable. So inside, we'll say var components, I'm tired of typing this word, equal URL components, and the initializer for this takes a URL instance as a string, and this is a failable one. So we're going to pass in the base, if I can type. Now this base, this value we're getting from the endpoint, we know that at some point, a type that conforms to endpoint is going to provide this base. So in the default implementation, we'll access that. So this is a failable property or an initializer, as I mentioned, so we're going to force unwrap it. If it can't properly parse our base URL, it returns nil, and we don't want that. So I'm going to force unwrap this because I don't want to deal with the optional. Since our base URL is going to be fixed and defined by the type that conforms to endpoint, we'll know the base at compile time and can ensure that it is a valid URL that can be parsed. URL components contains stored properties that model and maintain a reference to the individual parts of the URL. So we can simply say components.path equal path. This is the value that, again, we're getting from the type that conforms to this protocol. And we'll do the same thing for the query items. So components.queryItems equal query items. And that's all there is to it. The components object will now construct the entire URL using all these constituent parts. So we can go ahead and return it. Once we have the components, creating a request is actually very easy. So we'll say var request, and this is of type URL request. And in here, we'll say let URL equal URL components, which is our computed property. And we'll access the URL property to get a fully constructed URL. Now, this is also an optional property, but again, I'm force unwrapping. And that is because I want this to crash if I haven't configured everything properly. We now have all the information and knowledge on how to create the URL at compile time, so we'll ensure that this is right and we don't crash. All that's left to do is return a URL request instance with a URL. And with that, we've completed the logic on how we're going to create URLs for this app. At this point, all we need to do to get a valid iTunes Search API URL is to make this enum, iTunes, conform to Endpoint and provide the necessary computed properties for the base, path, and query items. Let's do that in the next video.